Dear students, let's see this question. In this question, a medium having dielectric constant K, which is greater than 1, fills the space between the plates of parallel plate capacitor. The plates have large area and the distance between them is d. The capacitor is connected to a battery of voltage V as shown in figure. Now both the plates are moved by a distance of d by 2 from the original position as shown in figure B. See here, two situations are given. Here capacitor is connected to the potential V, and in the capacitor a dielectric slab of dielectric constant K is filled, and the plate separation is given as D. Now what he is doing? He is separating the plates in such a way that the separation between the two plates becomes 2D, and dielectric slab of thickness D, and here gap d by 2 and d by 2 will be there. Again he is saying that in this process of going from configuration depicted in figure to that in figure B, which of the following statement is are true? He is asking that 4 options are given, 4 statements are given. He is asking that which statement or which are statements are correct. Now we will see one by one. First one is given as first statement. The electric field inside the dielectric material is reduced by a factor of 2K. He is saying that electric field is reduced by a factor of 2K. Now we will see. See, if you see electric field formula in between the two plates, V by D. E is equal to V by D. Now when the separation becomes 2D, then E becomes V by 2D. I will write this is E dash. So E dash can be written as E by 2. Electric field is reduced by a factor of 2. It is not 2K. Again I am saying electric field intensity is reduced by a factor of 2. It is not 2K. Hence option A is wrong one. A is wrong option. And we will go for the next option. Now see the second option. What is given? The capacitance is decreased by a factor of 1 by K plus 1. Now we will find out the effective capacitance. Initial condition, C is equal to K epsilon naught A by D. Why? Because in A, if you want to find out the capacitance, C is equal to K epsilon naught A by D. Now in B, final we will see. Here I will write, for example, C1, C2 and C3. And these C1, C2, C3 are connected in series. So first I will calculate C1, C2 and C3, and in series I will apply the formula. We will get the answer, and after that I will compare. See here, C1 can be written as epsilon naught A by D becomes D by 2. So here 2 will come. C2 can be written as this one, K epsilon naught A by D will come, and C3 will be, again for this C3 will be epsilon naught A by D, here D by 2, so here 2 epsilon naught A by D will come. These 3 capacitors are connected in series. So effective capacitance I will write C dash, 1 by C dash can be written as 1 by C1 plus 1 by C2 plus 1 by C3. I will find out, and after I will compare with the initial capacitance, so we will get the answer. We will see. See 1 by C dash can be written as 1 by C1. 1 by C1 is 2 epsilon A by D. So 2 epsilon naught A by D, so top D will come, plus 1 by C2. So here K epsilon naught A by D, so top will come, plus C3 again the same manner, 2 epsilon naught A by D, so here it is D top will come. So 1 by C dash can be written as, so here D is common and epsilon A is common, so D by epsilon naught A, if you will take common, just try to understand, here 1 by 2 is there, here also 1 by 2 will be there, plus 1 by K. So 1 by C dash can be written as D by epsilon naught A 1 plus 1 by k. 1 plus 1 by k. If you want to write further, 1 by c dash can be written as d by epsilon naught a into k plus 1 by k. K plus 1 by k. Now ultimately we can write c dash c dash can be written as epsilon naught a into k by d into k plus 1. Now see, initially k epsilon naught a by d came, finally k epsilon naught a by d by k plus 1. So we can write here c dash can be written as c by k plus 1. C by k plus 1. Just the option C. The capacitance is decreased by a factor of 1 by k plus 1. So capacitance decreased by a factor of 1 by k plus 1. So hence option B is correct one. So B is correct. Option B is correct. Now we'll see C and D. Now see option C and option D. Option C, the voltage between the capacitor is increased by a factor of k plus 1. He is saying that when we increase the separation from d to d by d to 2d, is asking that the voltage also increased. But one thing we understand, here we are giving the constant voltage and here we are giving the constant voltage. So in both the situations, voltage remains constant. In both the situation, voltage remains constant. But he is saying that it is increased by a factor. So it is wrong answer. It is wrong answer. And option D, I will write C is wrong. And option D, see, option D is saying the work done in the process does not depend upon the presence of dielectric material. See, the work done in the process does not depend upon the presence of dielectric. Just we will try to understand the concept. For example, if there is no dielectric, so initially the energy stored in the capacitor is half CV square, initial energy. And for example, when dielectric slab is placed having dielectric constant K. So here energy will be half K into CV square. Half K into CV square. And if you find out the work done is nothing but change the potential energy. So half CV square into K minus 1. So absolutely in this situation, while we are observing, work done depends upon the slab. Work done depends upon the dielectric constant. But here the question is saying that the work done in this process does not depend upon the presence of dielectric. The statement itself wrong. Whenever the dielectric slab is introduced, then automatically its capacitance will increase. When its capacitance will increase, capacitor has ability to store maximum charges. Then the cell has to send the excess charges to the capacitor. So again, the work done purely depends. But here is saying that statement D does not depends, which is again wrong. So here D option is also wrong. So if you observe this question, it is given in advanced 2022, same basic concepts. Option A is right and B, C, D is wrong. I hope you understood. Thank you.